All right. Welcome to The Explainer. Today, we're going to pull back the curtain on the science that plant breeders use to create the world's most productive crops. It is an amazing process of prediction, analysis, and, well, strategy that literally feeds the world. Okay, so let's just jump right into the central puzzle that plant breeders face every single day. You think, right, that if you take two champion, high-performing plants and cross them, you're guaranteed to get an even better super plant. But that's not what happens. The outcome is surprisingly unpredictable. So to figure out how scientists get around all this uncertainty, here's what we're going to do. We'll walk through the breeder's big dilemma, then we'll explain the two key tools they use, GCA and SCA, then we'll peek into their playbook, and finally, see how it all unlocks something incredible called hybrid vigor. So let's start right there, with the problem itself. A parent plant can have all these amazing qualities, what scientists call its phenotype, this stuff you can actually see, but that doesn't guarantee it's going to pass those traits down in a nice, neat, predictable way. And this sentence right here, that is the breeder's dilemma in a nutshell. Just because a plant looks fantastic, just because it's a top performer, that doesn't mean it has the right stuff genetically to be a great parent. How it looks isn't enough to tell you how its kids will turn out. To solve this, breeders needed something better than just looking at the parent. So they developed this powerful concept called combining ability. Think of it as a way to measure a parent's true genetic value, not just how it performs on its own, but how well it combines with others to pass on its best traits. Now, this idea of combining ability isn't just one simple thing. To really get it, you have to break it down into its two crucial parts. And these two parts tell you very, very different things about a parent's potential. And, this whole framework isn't new. It actually goes all the way back to 1942 with Sprigg and Tatum. Their idea was a total game changer. It gave breeders a systematic way to really dissect a plant's genetic potential and make way smarter decisions. Okay, this slide is where it all starts to click. Think of general combining ability, or GCA, like a baseball player's season batting average. It's how well that parent does on average when crossed with a whole bunch of different partners. It's reliable, it's heritable, but specific combining ability, SCA, that's different. That's like the incredible, unexpected chemistry between two specific players in one game. It can be amazing, but it's a one-time thing, unique to that single pair. So what's happening on a genetic level to cause this difference? Well, GCA is mostly about what we call additive genes. These are simple, stackable effects. You can consistently select for them and build them up over time. But SCA, that comes from all the complex, messy stuff. Non-additive effects like dominance, where one gene just totally masks another, or epistasis, where different genes interact in ways you just can't predict. That's what creates those unique, one-off superstars. All right, so breeders have these two powerful concepts, GCA and SCA. But how do they actually use them? How do they go from theory to actually making a decision? What's the playbook? Well, it's a really systematic four-step process. First, of course, you pick your group of promising parents. Second, you cross them, but in a very structured way, using a specific plan, a mating design. Third, you plant all those kids, you measure how they do, and you use that data to calculate the GCA and SCA values. And finally, you look at those numbers and decide on your strategy. And those mating designs, they give you data tables that look just like this. Every single number in this grid is an SCA value. It represents that unique chemistry for one specific cross. So a big positive number like that 0.1561, that's a great combination. But a big negative one like that negative 0.2376, yeah, that pairing was a dud. After all that data is collected and all the numbers are crunched, it really all comes down to this one crucial calculation, the ratio of GCA variance to SCA variance. This one number tells the breeder which kind of genetic action is running the show for the trait they care about. And this right here, this is the fork in the road. This is the moment of decision. If that GCA number is bigger, it means those simple additive genes are in control. The strategy is straightforward, selection. Just keep picking the best and breeding them to stack up those good genes. But if the SCA number is bigger, that tells you those complex, non-additive effects are dominant. Your strategy has to change. Now you're hunting for that one magical cross. You're doing heterosis breeding. And it's that second path, this heterosis breeding, that has given us some of the most mind-blowing gains in modern agriculture. This is where we get crops that just totally blow their parents out of the water. So what is heterosis? You probably know it as hybrid vigor. And honestly, it's that magic moment where the kid isn't just as good as its parents, it's way better than even the best parent. For things like crop yield, this is the holy grail. And this is where it all connects. You see, that high SCA value we saw in the data table? Well, that's basically a giant, flashing neon sign that points directly to heterosis. When a breeder sees a cross with a really high SCA, they know they've found a potential winner. They've found a pair whose unique genetic chemistry could create something special. But here's the really wild part. Where do these superstar hybrids come from? Sure, sometimes you cross two great parents and get a great kid. Makes sense. But sometimes, a parent with a pretty poor average performance can team up with another to create something amazing. And get this, sometimes you can cross two poor performing parents and end up with a stellar kid, just because their weird genetics happen to complement each other perfectly. So at the end of the day, that's what this is all about. Combining ability analysis takes the pure guesswork, the luck, out of a really complex process. It gives breeders a scientific roadmap to find those rare, amazing hybrids so they can be developed for all of us. And you know, this tool is more important today than ever before. As we face bigger and bigger challenges, breeders are using this exact same analysis to create crops with better yields, sure, but also with drought tolerance, disease resistance, and better nutrition. It's the fundamental strategy for building the future of our food.